Okay, so let me first talk about a question that some of you somewhere you have a comment star or comment pointer. Okay, you have a pointer looks like this, and some of you might have something looks like this. Comments, no, not comments. You have std vector comment star comments PTR or something like that. I shouldn't use comment S. I just use comment vector PTR. Okay, I have this two kind of situation here. Let me just change very quickly to a different font. Okay, so we have, I mean, just example, you might have case number one or case number two. So the issue that you encounter when you say that is because when you try to say do this, comment PTR, and then you try to do a new, right? New comment. And then this comment here that needs a bunch of parameters depending on what's your design about your in the comment.h or comment.cpp. So if you use my design, then we can take a look at the code. So it's ECS36B program, ECS36B homework 5. Yes. If you look at the design, it basically took, let me just copy this piece of code here. It basically took a bunch of parameter. Sorry, let me make it bigger and so we can fit in the page. Okay, this should work. If you look at here, it took 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. It took 6 parameter for this to be so it's expecting you have 6 parameter. So if when you call this, you need to have those 6 parameter ready for you to put it in. All right, so that's just the design of the comment constructor. That's why you saw that error message, because you need to put that. I think somebody else already provided an answer similar to that. Okay, so is that okay so far?
Yeah, so you're just saying so like for example, I only put like from message created time and then like or the time and the person, but then I should also need to put the post ID and the comment ID.
Yes, you need to put profile ID, post ID, and comment ID, and those are going to be extracted from the ID string. The ID string is something like this format. The ID string, let me just write down here. It's like the ID string is profile ID first, and then with an underscore, and then with a post ID, and then with a comment ID. So that's the format, and that's how you actually parse it out to have the 3. But I said this is my design. My design, I actually split that into 3. But some of the students could put the whole thing as 1, and that's fine with me. But you just need to recognize that, especially when you do merge, you want to make sure that their ID, at least the profile part and the post part, they should be identical for 2 of the post. So for example, the example I provide, the base update, the base JSON. If you look at the base JSON and the update 1 and update 2 JSON, their ID part are identical. So that's something you need to match. Yeah. But this is the design of this particular comment. If you use my format, then yes, I separate it out into 3 different strings.
Okay, thanks.
Okay, all right. So I'm going to continue with this example because this example, it actually helped for me to explain some of the struggle you encounter. Many of you, not just here, that when they have a segmentation fault. Okay, so essentially what I'm saying here is that I'm going to only focus on this part. Essentially, when you call this, when you actually decide to call this new comment and with a bunch of things, and you're actually going to input like a person object pointer, message object pointer, and JV time pointer. So in other words, that if you did not allocate for example, some of the students, let me just make a copy here. Some of the students, let me show you what they did, okay? So what they did is for example, they define a JV time pointer, JV PTR. Okay, they did that, and then they actually create a comment using that pointer there. But much later, when they parse the string, when they really doing this parsing, here is really doing the parsing for the time, parsing the JSON time. And until over here, they actually, after the parsing, they start to do JV PTR is equal to new JV time, whatever. Okay, there is also some data structure you need to put in as this. Okay. Okay, if you've done this, and then you will get a segmentation fault, because what you have is when you create a new comment, at this time, even though you didn't see that, but the value of this is essentially null. The pointer is a null pointer when you declare that, or some other random value, even worse. So the memory was not assigned until you call this new JV time. And therefore, you already assigned the value of the JV time into to construct a comment object, which is already include, but take a pointer as a null pointer. And then people try to use this, they didn't check if this is null. If it's null, you shouldn't use it. But anyway, some of them just call dump J on the comment. When they do that, you're going to have a segmentation fault because the pointer is null. So anytime when you have a pointer is null, and when you want to dereference the pointer, I mean, for example, if somebody do this, this will be a null. For example, assuming JVPTR has a variable called x, and you try to access to that x. So remember, JVPTR at this point is still a null. When you haven't initialized the pointer, you try to reference one of the variable, and this is going to accessing essentially this is equivalent to say, hey, I have a pointer void star. Okay, I will actually use this way. I have a pointer called JV time star. I casting, but the value is a 0. And I want to access to x, variable x. So these 2 lines are actually identical. And when you have this line, you're trying to access the memory address of 0, which is by the design of operating system, is you're accessing a area which is prohibit for you to access, and that's the segmentation fault. That's why you have a segmentation fault. Anytime you try to access some memory, that's you're not supposed to access. Which the example I provide here and the experience that many of you share in the past few days is actually this root cause. So when people gave me that piece of segment of code, I always check this kind of thing. I've always found one or more such kind of uninitialized pointer, and you try to access, and that's the reason. Okay, to illustrate the things a little bit further, I'm actually providing some slides for you to just understand what's going on here. So so I was thinking about, just using this as a kind of part of the lecture to tell people what segmentation fault really is. So if you think about, you have to think about memory layout. Okay, so think about memory layout. So I want to tell you that what's a memory layout? Memory layout looks like this. So your memory have some kind of higher address and all the way to a lower address, okay? So every single address that has its purpose. The first part, the higher address, the one like at the top 25% of the memory address is allocated to the operating system kernel, which you will learn a lot from ECS 150. And there is something called stack and heap. You probably heard me already saying a lot about the term about this is on stack, this is on heap. I will actually explain to you a little bit better. But then there is another part, it's called data. The data part is like, just give you an example, your static variable, your global variable, your virtual table, and a lot of things is actually on the data and the text side. The text is your code, your function, your lambda expression, your any kind of code related to your member function, any code is putting in text. So you see that this is your address space. Okay, this is your address space. So when you actually access a zero, guess what you're doing is when you are dereference the zero, you're actually access this part, right? This is the lowest address. And so the thing is that then the operating system is thinking, well, how do I actually differentiate that you're actually doing a dereference of the null pointer, which is unintentional. That's your logical error that you try to access to zero, or you try to access piece of code in this region. So how does operating system actually differentiate whether it's you intentionally access to this region, or you had a bug like what you had, some of you, not all of you, that actually try to access to that. So, okay, how do I differentiate that? So they do something very smart, and I want to show you what they did. So this is the memory layout. Okay, this is a memory layout for a typical Linux or Unix environment. This has been, the same layout has been there for probably 50 years, just like in our system. So this is the memory layout. This is the highest level. So this is more detail. I'm going to make it a little bit bigger so you can probably see better. Okay, so so this is the layout. On the top of this is the kernel, just like what we have. But this now I have a more detail, and this is the lowest. This is the lowest. But have you noticed that the lowest, the address here, is not starting with a 0000. It's actually, this is a hexadecimal. It actually start with 0x000100. So it means that this part is your A dot out. When you use compilers, generate the A dot out, it has two parts. One is your text. Text means your code, your function, everything. And then you have your initialized data. What's initialized data? Including your static variable and this global variable and a bunch of other data. That this is going to be mapped into this region, but it's all started with 1000. They intentionally skip from 000 to 0FFF. Okay, they skip the first 1K or whatever the amount of memory that the first lowest address is this. So in terms of this memory layout mapping, nobody in the regular program should actually access any address that's smaller than this value, smaller than 0000100. So if you dereference a null pointer, it will definitely try to access some area that below this arrow. And therefore, the operating system knows that's a segmentation fault. You're accessing something which is you're not supposed to access. Okay. By the way, you might get other segmentation fault. For example, your program shouldn't touch the kernel address space. If you actually really try to access some number, which is a huge, tap into the memory address space, that could be a segmentation fault, or sometimes you get a bus error. So that's kind of the give you some sense that why you're getting that address, why you're getting that signal called segmentation fault, and that usually related, most of them related to reference a null pointer down here, because the chance you're going to get this is very small because the address is pretty high. So you get that is actually lower under here. Okay. Okay. So any question?
Yeah.
Go ahead, please.
Should we have like different HOMO5 produced files for parts 1 and 2?
Okay, let me turn off my recording first, and then I will do something. It's a different topic.